Let's do some math today. Statistics. Okay, so this goes with lesson 2E, part A. Part A just went through what variance and standard deviation is and how to calculate it. And now we're actually going to do some of the questions. So some of those questions in exercise 2E requires you to use a calculator as well. So I'm going to go through a selection of those. And this will support you when you do it. So I'm not going to go through them all, so you can fill in the gaps. Okay, but I thought I'd go through question 1, question 4 because it says it's a problem, question 5 because it's the first one where they're in a table, and question 7 because it's sort of it's the last one from the end. It's sort of a problem, but also it's continuous data in a table, so I'm going to show you how to put those in a calculator. Okay, so here we go. Put those there. So the first one then, for question 1, it says for a given variable x, so that's a set of numbers that is called, or each one of those numbers is called x. The sum of x is 24, the sum of x squared is 78, and n equals 8. In other words, there are 8 numbers, and you've got to find the mean, the variance, which is this little symbol squared, and the standard deviation, which is this symbol. Okay, so for part A, the mean, remember the symbol is that, isn't it? And it's the sum of the numbers, it's all the numbers added up, and it tells you that it's 24. The sum of the numbers divided by how many there are, there's 8, so the mean is 3. That's simple. So it gives you some summary data in this question. Okay, it gives you some summary data in the next question as well. Remember, there is that other summary data that I talked about in the last lesson, you know, that has a capital S, and that gives you, if you see that with, you know, XX or 2 letters there, it is that x minus x bar sort of squared. Or if you get given that, all you need to do is divide by n to get the variance and square root the whole lot to get the standard deviation. It's the other version, it comes from the other version of the standard deviation formula. Okay, the one that we don't actually use. Okay, we use the version that I'm going to use now for part B and C. Okay, so part B, the variance, so that's that squared. Okay, and that is equal to, it's the sum of x squared over n minus the mean squared. So you might see it written like that. I'm going to change this in a minute because that's the symbol. That's how you find the mean, is it the sum of x, the sum of the numbers divided by how many there are. But in future, I'm just going to do that, okay, because it's just simpler. So that's what we're going to do, and that's why they're giving you this summary data. So we're going to go 78 divided by 8 and minus 3 squared, which is 9. And if we put all of that into a calculator, I did it before, it gives you 0.75. Okay, and see that the standard deviation is just the square root of that. So 0.75 square rooted gives you 0.866. Okay, so the mean is 3, the standard deviation is 0.75. Sorry, the variance is 0.75. We don't really use the variance much. The standard deviation is 0.866. That's the important measure. Okay, so that's question 1 done. Make sure you have a go at these before you watch this. So have a go at question 4, for instance, before you watch me do it. Question 4, I did this one because it's got a P next to it saying it's a problem. Not really much of a problem. It's saying for a set of 10 numbers, to me it seems really straightforward. A set of 10 numbers, and for those numbers the sum of x is 50 and the sum of x squared is 310, and for a different set of 15 numbers the sum of x is 86 and the sum of x squared is 568. Okay, so it says find the mean and standard deviation of all of them together, in other words the full 25 numbers. Well, the standard, what does it say, the mean, okay, so the mean of all 25 is equal to the sum of x, sum of all 25 divided by 25. Okay, so, and the sum of x is all of those together, isn't it? The 50 add the 86. You know, those 10 add up to 50 and those 15 add up to 86, then the 25 add up to 136 over 25. Okay, so that's the mean. Whatever that works out to be, I did work that one out. What did I get for that? 5.44. Exactly, I haven't rounded that off. That's what it was. And then using, it wants the standard deviation now, so that's the square root. We're going to square root it in the end. The sum of x squared over n minus squared. In other words, is the square root of, so it's these two added together, so 310 plus 568 all over 25. Okay, the sum of all of the x squareds divided by how many there are minus the 5.44 squared. And you put all that into your calculator, which I did. I got 2.35, which was the right answer. And that's the standard deviation. Okay. All right. So, next thing's how. Remember in the last lesson I showed you how to do it on a calculator, so I wanted to do this one and this one because we're going to do those on the calculator. So number 5. So there's a pocket money survey that this kid is doing, and he tells his friends to round their pocket money off to the nearest pound. So some kids said they got 8 quid, in other words between £7.50 and £8.50, you know, rounded to £8. Some kids said they got £9, so in other words between £8.50 and £9.50. So they're actually little groups, those, aren't they? Okay. And 14 kids said they got £8, 8 kids said they got £9, 28 kids said £10, and so on and so on and so on. These are the spoilt ones that get 12 quid. Okay, and you've got to first of all work out standard, the mean and standard deviation on the calculator. Okay, so here goes. Get that there. You can sort of see that. So first of all, you need to go to menu, and we want the statistics one, which I think, I know once you know it, 6. In future, you don't need to move the cursor to it. You just need to press 6 when you first go into the menu. So I'm going to press 6. Okay. And then we want the one variable, so we press 1 and it comes to the table. Now the frequency x is this one here, the top row. Sorry, x is the top row, not the frequency, that's that one there. And it automatically puts a frequency of 1 as if they were just single numbers, 8, 9, 10, 11, 12. In other words, if you just had 5 kids, we've got more than 5 kids, we've got all of these here. Okay, so you just put those numbers in, so you press 8 for that first one and you press equals and it automatically moves down, so we put these numbers in first. So 9 equals 10 equals 11 equals and 12 equals. There you go, put those in. Then I move my cursor back up carefully till I get to the line that's 1 next to the 8, and there's actually 14 students, so we're going to change that frequency from 1 to 14, and you just do that by typing in 14 and pressing equals. Okay, so 8 equals 28 equals 15 equals, and what was the last one, the spoilt ones, 20 equals. There we go. So we've put all that data in the table. It is actually continuous data, so if there's a group, all we're going to do with this next one is just put the midpoint of the group in. That's all you do. Okay, so there we go. So once you've done that, it took me about half an hour to work this out. You then go to option, okay, and you want line number 3 that says one variable calculations. Okay, so you press 3 and it gives you all that data there, and that's it. That's how you do it on your calculator. So the mean is the top one, so 10.22, and the standard deviation is 1.349, so 1.35 standard deviation. They've put it standard deviation of x, so 1.35. There we go. Okay, I'm just going to change it back to 1 now, and now it's back in its normal mode for the next bit of the calculation. Okay, so I've got that, and I know that's right. Did it on my calculator. It says how many students the next bit here, so the next bit is the problem. It says how many students received an amount of more than one standard deviation above the mean. Okay, so this is going to be an interpolation problem, isn't it? So 10.22 add 1.35 is £11.57. So we're saying how many students got more pocket money than £11.57. Okay, well, if you look at this now, there's £11 and that group goes up to £11.50. So you're talking how many students in this group here, okay? And how far are we into this group? Well, this group goes up to £11.50, so the 12-pounders, are the students that get £11.50 up to £12.50, don't they? That's what they do. That's that group, okay? In other words, there's 100 pence in that group, okay? So that's the width of the group, and it's got a group width, a class width of 100 pence, and there are 20 in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. Okay, so 100 divided by 20 gives you 5 pence, doesn't it? Okay, so in that group, each student, you know, the assumption that we make when you're doing interpolation, and in fact that's the answer to the very question 8, by the way, if you go into that, so state one assumption you've made in producing this estimate. Well, the assumption that we're going to make is that everyone in this group is consistently sort of spaced out in the group. Okay, so 5p. Now remember, out of these 20 students, so there's our £11.50 at the start of the group, and remember it's going up in 5p's, so got to be careful here. That's £11.55, that's £11.60, and so on. That's £11.65, right the way up to, you know, going up to the £12.50. So we've got 20 students in that group. Now in this group, of course, one student, £11.50, rounds up to £12. So there's one student that gets £11.50. So it actually starts from that limit, okay? There's a student that gets £11.55, so that's another student there. So that's 2 students so far. The next student, so there's our £11.57, there, £11.57. So there's 2 students in that group that get below £11.57. The student that gets £11.50 and the student that gets £11.55. So that means there's 18 students that get above £11.57. Okay, that's the £11.60, £11.65, £11.70, and so on. Okay, so that's your answer. It's 18 students. I think there was a deliberation in the last lesson, wasn't there, over those slow worms about how many, and I think that's perhaps what I should have done, thought about, right, when you're rounding up to the length, you round up, you start from the actual sort of limit, because that would be one that rounds up. Okay, anyway, just waffling now. So there are 18 students above the mean. Okay, and the last one I'm going to do is question 7, and again we'll do that on the calculator. Okay, so question 7, it says a machine contained a part that tends to wear out in this machine. So they run the machines, and this particular part that they made, it wears out, a bit of a pain in the backside. So they tested 50 machines running with this part in, and this is the survey. So out of those 50 machines, 5 of them, that part only lasted between 5 and 10 hours. 14 of the machines, it lasted between 10 and 15. Anyway, that's what happened. And the people that make the machines or make the parts claim that 90% of the parts tested lasted longer than 1 standard deviation below the mean. Okay, so we've got to find the mean, got to go 1 standard deviation and see whether 90% of them lasted more than that. Okay, see whether that claim is right. Okay, let's do that then. first of all, we need to find the mean and the standard deviation, don't we? So we want the mean and we want the standard deviation. So, switch our calculator on, menu. We know it's 6 now, so we can just go straight to 6. Press 6. Okay, and I'm going to go, we want the 1, so we want 1, and we're back to our table. Now here, I'm going to put in this, but I'm going to put the midpoint in. So between 5 and 10 is 7.5, so I'm going to go 7.5 equals 12.5 equals 17.5 equals 22.5 equals and 27.5. There's all my midpoints in. Now I just need to change my frequencies, go up to 1, and I want 5 equals 14 equals 23 equals 6 equals and 2 equals. So I've got all the data in, and nice and easy. Option, select 3, and there it is. So we've got a mean of 16.1 and a standard deviation, what's that, 4.69. Okay, so there's a standard deviation of 4.69. Alright, now I'm going to go out of this mode now. Why? I don't know, actually. Okay, so we want tested one standard deviation below the mean. So there's the mean, there's a one standard deviation. So we go 16.1, 1 standard deviation below mean is equal to 16.1 minus 4.69. So 16.1 minus 4.69 is equal to 11.41. Right, okay, so let's have a think about this now. 11.41. So what are they saying? They are saying that 90% of these machines, or this part, 90% of them lasted longer than 11.41 hours, because that is one standard deviation less than the mean. Okay, so they're saying 90% tested, so we've got to comment on that, whether that's a false or a correct claim. 90% tested lasted longer than that. So what they're saying is 90% is well, 10 is 45, isn't it? So 45 parts, because 10% of 50 is 5, so 90% is 45. So 45 parts lasted 11.41, more than 11.41 hours. Okay, I doubt whether that is going to be right, actually, because now we can see that there's already 5 parts that are in this first group that lasted less than that. Okay, so it's not going to be right, but let's work out so we can say for why it's wrong. So we're looking at this group here. Okay, the 10 to 15 is 5 hour class width, isn't it? Okay, and there's 14 in that group. Okay, so what we're saying is that 11, where is this 11? How many of those 14 is this take 11.41? Well, what percentage into this? So this is 11 hours 41.41 minutes. It's sorry, 0.41 hours. It's not 41 minutes. Is 1.41 hours into this group, isn't it? So it's 1.41 out of 5 hours. That's what fraction it's into the group, this bit here. Okay, and how many machines would that take times 14 machines? Okay, is 1.41 divided by 5, so it's 0.2, it's almost 30% into this group, So it's 30% of this times, or 28% of this, so times by 14 is equal to 3.9. Okay, 3.948. Okay, so that means that it's these 5 and another 3.98. In other words, another sort of 4 machines, you know, into this group here. Okay, so total machines, so you've got 5 that's in this group plus 3.9, so plus another 4, you know, in that group is 9 machines, is my estimate. So 9 machines last less than, you know, this limit here. So that means that only 41 machines last longer than 1 standard deviation below the mean, doesn't it? Okay, because we've worked out that 9th limit, so we, you know, that is sort of a different way round of doing it than we've done it before. And so we're saying, where is, you know, 1141 in this group? Well, it's 1 hour, it's 1.41 hours into this group, 1.41, you know, out of the 5 hours. So that fraction, isn't it, of the group, you know, of a group of 14, so of 14 machines, so it represents 4 machines. So 41 machines, and of course 41 out of 50 is 82%, isn't it? 41 out of 50 is 82 out of 100, so it's 82. So they can't say that. They can't say 90% tested longer than one. They've got to say only 82% is the correct claim, lasted longer than 1 standard deviation below the mean. Okay. All right, so into the calculator, you know, midpoint times frequency, and again some more interpolation. I hope you're getting used to your interpolation, doing it different ways and so on. Yeah, it's good fun, isn't it? Okay. The last one, I haven't done the last one. It's just similar, wind speed and so on. So you can do that. It's similar to this one, I think. Okay, it gives you the summary data, so it's fine. Okay. All right, over and out.